Okay, so your material is taken, your cross section is assigned. Next, moving to assembly, I'll create an instance. Then I'll go for step. Yes, for the step, I'll take general static, that is static analysis itself. Okay, so here you can change your load, incremental, anything if you want. Otherwise, as you keep the same, no issue. So step is created, your load is created. So boundary condition I'll fix here at the bottom. Now the other, I am applying a load. I'll take here as a pressure at the top surface. Now considering 100 MPa. Okay, I'll consider 100 MPa on the surface. Okay, now you can see that you have applied 100 MPa at the above and you are constrained at the below, and you have applied a material and everything. Mesh seeding has been done. I'll take 2.5 so that you'll get a more proper mesh size. Now you can see that you have applied material, boundary condition and mesh also. Now directly go for job. Submit. So it will take only 2 to 3 minutes so that you can view a result. So it is done now. When you look to the results, now you can say that the stresses are 105, right? So I'll just take a screenshot of this so that we'll give a comparison of both. Now same similarly I'll take for the displacement. It is 0.02. Yes, so everyone understood this. Like what we have done, we applied a pressure on the top and we have constrained at the bottom. So this I'll close it now. So one more thing, so what was the height of this parametric sketch? Okay, 14 in the sense 14 mm is the height of the structure. So similarly if I take the same thing here, axis symmetric, the option need to be changed from 3D to axis symmetric. Okay, so again here shell or wire or point. I do require shell because I want to create only half of that. So I'll take shell. Now keep in mind always, this is your axis. You always should model your model towards right or left, one sided. For axis symmetry, make sure that your axis right or left you model at one side. You cannot do it this way. Okay, so that gives you the error. So what I'll do, I'll take the same thing in this manner. No. with the same height. Okay. I think it's 14 or 7 in this one. Yes. So what I'll do, I'll close this, I'll enter. You can see that you got a plane, only plane here, which is on the axis side. So again the same thing you need to do. Property, create a property, density, elasticity. Everything will be same here. There is no change at all. Only the change is to consider initially the axisymmetric or 3D or 2D. Point 3. Then assign. Here make sure that you are taking solid here. But as your surface or your geometry is 2D, but we are considering this as axisymmetric 3D model, consider this as a solid. Okay. So continue. You have created. Next, assign the same thing to your geometry. Now your material is assigned and a section is assigned here. Go to assembly, create an instance. Yes. And then step, same thing, no change at all. Static analysis, keep everything as same. Interaction, there is no nothing. Sorry. No. Interaction also nothing. So applied load, boundary condition, same thing. Here boundary condition will be applied only at the line, end line. Okay. So ensure same thing, casters, and then apply load, same pressure load at the top. Same value. How much it was? 100, right? So I'll take the same value, 100 pressure is applied on the surface, and do the mesh. So your mesh is also generated. Now solve the problem. Now it is solved. Check for the results. As now you see, you can see that, right? The same result, same pressure, same everything. Now you want to see your model completely. It is now 2D only surface. How do you ensure that your model is 360? Once. Display entity. 1 second. Axisymmetric formation. One second, we can view all the entire solid itself. Options. One second, let me check. Wireframe label. 360. Yes, you can see that your model completely now. How much degree you want to rotate it and how much segments you require. If I require more, what I'll do, I'll just click on it, the number of segments, which gives you more clarity on the same thing. We have taken everything the same, only we have changed with your comparison of stress. You can see that. Yes, the same result. The change might be due to the element height or the size of your solid. Okay, but you will get exact result when you take the same length or height. Yes, so option is, initially we need to take the option for axisymmetry is like, initially we need to take prior to take 3D. I love this. Now you can see the option is to take a axisymmetric axis there and model your model at one of the axis. If you are modeling your on the entire screen, if I consider the same thing on the entire screen, you need to create the axis at the left or right of its own. You need to generate the axis for that, for the rotation. Okay, so that is very important to create this. Yes, any doubt here? Everything will be same. Your boundary condition, loads, everything will be same. And while visualization, you have the option to get half of a model or 360 of your model. Yes. So any doubt here? No, right? Practice more. Practice. If any doubt, let me know that. हाँ सर.